All right, number 5 from the quiz, which is clearly the harder problem. It is a problem which has in it a combination. How do I know it's a combination? Because now if I look, let's see if I can get my pen. Never can find my pen. There's my pen. All right. So if I look, an electron coming out of here could go this way or this way. Hey, that makes it parallel. But then electron goes through this one, also has to go through this one, right? So these two are in series. This lump is in parallel with this lump, which is in parallel with this lump. Now, it's a fairly easy combination circuit. Why do I say it's a fairly easy combination circuit? Because if you look down here, 10 and 5, that everything's going through both of these, right? So this is like one resistor with a resistance of 15, right? 10 plus 5, that's how we do series. There's 15 ohms. So this backside could be treated just like one resistor with 15 ohms in it. All right. So now, reasoning. The ammeter is in a weird spot. It's right here, which means if you're an electron and you're zipping through the circuit, boom, you go this way. Are you going to go through the ammeter? Yeah, I'm going back to the battery. I'm out of here, right? And some of you are really concerned about backwards forwards. Let's pretend like you're an electron. You come out of this side of the battery, which you wouldn't. This is the positive of the battery. Positive flow of charge. But if I go this way through this resistor, I'm not going through that ammeter, right? So this piece ain't going to matter at all. Makes no difference. Nothing's happening here. The electrons that go through here don't care at all what's happening over here. Not even a little bit. Okay. I'm going to go back to pretend like I'm an electron zipping around the thing. Now, if I go through this route, yep, I'm going through there. And if I go through this route, I go through it. So I have to figure out how much is going through this way and how much is going through that one there. Okay. So these are in parallel. Remember how to do parallel? Parallel, yeah. Each one has to lose all the voltage. Because I have 100 volts, I'm going to lose 100 volts going through here because there's no other resistors in my path. Electron goes this way, nothing else blocks it. It's going right through that resistor and it's getting back to the battery. No stress at all. So therefore, we do a quick V equals IR. And I get my voltage is 100. I get to use all 100 volts again because there's no other resistors in that path. So I equals 5 amps. And so I get 5 amps going that way. Agreed? Agreed. Okay, so I've got 5 amps going that way. Boop. Now, what about this route over here? What about this route over on this backside? Well, this backside, we have 2 resistors. Now, I could go back through and redo it, but we know it's going to be treated like one big 15 ohm resistor, right? So therefore, V equals IR. Voltage is 100 equals I times the current, the resistance through there is 15. Whoop. So 100 divided by 15, I get on my handy dandy calculator if I can't do that in my head. And I get 6.667. So, I'm going to miss on my pen. I equals 6.67 amps. And so 6.67 amps is going this way on this route. And 5 amps is going that way, right? Well, how much is going through that ammeter? Well, both of them go through this ammeter, right? So 5 amps is flowing through one wire, plus another 6.67 amps is flowing through the other wire, so a total of 11.7 amps is going through that ammeter. The ammeter would read 11.7 amps. All right. That works. Okay? There's another way you could look at it. You could do total resistance if you wanted to. And then if you did total resistance, which is one of the ways I taught you to do this, so go ahead and I'll talk about that. If you did total resistance, you would recognize, again, that this backside over here is 10 plus 5 is 15. It's in parallel with a 20, we're parallel with a 20. So I go 1 over RT equals 1 over 20. By the way, this is a full solution. We're done. But let's talk about another way you could do this. 1 over 20 plus 1 over 15, right? So I grab my handy dandy calculator. I go 1 divided by 20 plus 1 divided by 20 plus, oh, that's not a plus sign. Sorry. Plus 1 divided by 15. Boom. 1 divided by shift answer. And I get the total resistance of the whole entire circuit is 6. All right? So if that's 6 ohms, every choice, okay? Then V total equals I total R total. Voltage total is 100. I total, I don't know. Resistance total is 6. So I divide that across. I do 100 divided by 6. Boom. I get 16. I get 16.67 amps, right? Okay. Now that I have that, I have to figure out how much is going this way, right? Well, it's in parallel. So I just do V equals IR. I'm using all 100 volts. Current is I don't know, but the resistance is 20. So my current would be 5 amps. So now that I know 5 amps is going this way, I know that the remaining amperage, which is 11.67, must be going this way. And after that, I'm done, because whether it goes this way or this way, it all has to come through this ammeter, right? And so there must be 11.7 amps coming out that back end. That's another way you could have done the problem. Totally fine. Either way, nothing's a big deal, okay? There's actually a third way, but we're not going to talk about that, because why do 3 different ways when we're confused about finding one good way to do it? So either one of those will work fine. If this isn't good enough, let me know. I will try to make another video.